Oh, hey there, everybody. I didn't even notice you there. Is that you? I was just coming back from my lab where I was doing explosive experiments, as you can see from my goggles. Look, they're cracked. Anyway, as we all know, I do many scientific explosive experiments, but today we're talking about something that hopefully is not so explosive, except for in fun, if you count that. Anyway, today we're going to be talking about the cyclotron, a very important device in today's modern culture. The cyclotron is used to accelerate charged particles, or protons, into other atoms, so that the atoms break apart and make radioactive isotopes, which are then used for medical purposes, studied in order to find cures for other things, other diseases, all very useful in the medical purposes, and also some other few uses. But the process is really the interesting part that we want to look at today, because it uses electromagnetism, as you might have guessed, otherwise I wouldn't be talking on this podcast. What happens is the cyclotron has two electrodes in a vacuum between two electromagnets. The electromagnets are shaped like giant Ds, although in the camera it probably doesn't make the right shape. And not surprisingly, these electromagnets are called Ds. That's right, there are two of them. What they do is the charge drags particles to the Ds, and the magnetic field moves it in a circular path, and as it moves, it starts to go faster and faster and faster. What happens is that this electric field alternates between the Ds, and the particle speeds up every time it enters another field or crosses space in between the Ds. Thus, it's using the third principle of electromagnetism. Changing magnetic field through a loop of wire causes a current in the wire that the current opposes the charge that produces it. In simpler terms, when the charge switches over to the other D, it propels the particle faster and faster, and each time it switches, it accelerates the particle. And what happens is it goes around the Ds and around the Ds, and it slowly moves its way to the outside, and each time the loop gets bigger, but the time that it takes to complete the loop remains the exact same. Thus, it is accelerating. And as it accelerates to the outside of the Ds, it is aimed towards the particle, or the atom, in which it wants to collide with. The only problem being is that when it gets to the outside of the Ds, sometimes the control is less, and thus it's a little harder to keep control of the particle, but that's not a huge problem because usually it is directed towards the atom in the first place and reaches its target and produces radioactive isotopes. And so that is the cyclotron, using the third principle of electromagnetism, important in our uses, and intriguing. I suggest that you do more research. So, for more research, you can go to the same site that I went to, which is at howstuffworks.com/cyclotron-info.htm, as they like to say on shows, for more information. Well, I need to get back to the lab. I mean, I might have to rebuild it from scratch, but that's the way things go. Anyway, I hope you've enjoyed this podcast movie, and tune in again, because I'm going to be spending a lot of time building a lab, and I might just want to talk about another thing. See you! Have a nice